Okay, guys, now we're going to look at the structure of proteins, all right? And you can kind of read this, and it's the same thing I have written over here. There's nothing too crazy. Uh, Primary structure, this determines properties and functions. Can two proteins be composed of the same amino acid? The answer is yes. Remember, order is important. Uh, your secondary structure is if you have an alpha helix. This is myosin in the muscle. And what this does is it means that the R groups are going to extend out. And I'm going to show you these pictures here. I'm trying to draw your attention to these pages. Then there's alpha keratin, which is in hair, and this is used as a right hand twist in order to get those straight chains. Uh, Beta pleated sheets, it's a sheet, so all the proteins are lined up kind of in a sheet, and the R groups are above and below the sheet. And in these, the R group is usually small. You can't really have large structures there. Um, Tertiary, this is stabilized by intermolecular forces, which we're going to talk about in a minute, and disulfide bonds, the only covalent bond stabilizer in that. And then the quaternary structure is each chain is a subunit, and we're going to look at that right now. So I'll look at number 10 for a minute, and then we'll jump down. So intermolecular forces, there's London dispersion forces, dipole-dipole interactions, and hydrogen bonding, and disulfide bonds. The peptides are going to line up to maximize these attractive forces because they want to stick together. We're very happy that proteins stick together, i.e., that's why you have your hair because that stuff sticks together. And then insulin. Insulin consists of two polypeptide chains that are held together by two disulfide bonds. And this is made in the pancreas. All right. Now, type 1 diabetes, these are people born with a genetic disposition to not construct this protein. And we're going to look at where it comes from in a moment. First, these are the pictures from your book. So I want to make sure that you understand that these are right there for you. This is your right-handed alpha helix. This is the backbone of the alpha helix. You can see it's got this right-hand turn. You have these R groups that are sticking out. This is a beta pleated sheet. You can see the R groups, which is yellow things sticking above and below this sheet, and they're trying to shade in and show you what those sheets are. So here, this is just a breakdown of what's going on in terms of size of structure for proteins. Here's your primary structure, right? You have your chain. Alpha helixes it's called a ribbon structure. You have these, spiraling green ribbons, and then your beta pleated sheets are going to be kind of these weaving purple things. So you have your protein, boom, beta pleated sheet, alpha helix, boom. This is your tertiary structure. Okay, so you can see it's a little bigger. You can see all those twists and turns and beta pleated sheets. And then your quaternary structure, the protein complex of polypeptide chains. So you can see there's a whole lot of stuff going on. So it becomes very difficult to talk about the chemical structure of a protein simply because there's just so much happening. So we're going to stick with this. We are essentially going to be focused on the primary structure. Uh, just as a little heads up, here's a little blurb on insulin, which I think is very interesting. People used to, well, here you go, our pancreas, there it is. These are this structure and then space filling model for insulin. Um, People who needed insulin used to get it from pigs or cows. That's where we had to isolate it from, and people could use it. It would still do the same thing to their bodies. So that was a great find. But now we engineer human insulin, and so people can take just regular insulin. So this has been a huge deal. It was a magnificent discovery. And actually, right now, I read somewhere that there are certain states that are now capping the price of insulin, so those with diabetes they don't get price gouged for something that they absolutely need. So this is proteins. Here's a little bit on insulin.